The next section, 1.5 in chapter 1, is titled Definitions of Derived Units, sort of a continuation of section 1.4, where we define the base units. But this is a good representation of this idea of derived units being combinations of base units. So for instance, we look at the first one on our list here. Let me pull this up so we can share this and look together. But you look at the first one here, and this is the listing from page 5 in your textbook. It says the coulomb is the quantity of electricity transported in 1 second being a base unit, by a current of 1 ampere. Ampere being a base unit again. So combination of the two, 1 ampere per 1 second. It's the amount of electricity transported, and we give that amount the name coulomb, a derived unit. Our measure of temperature, base unit wise, is the Kelvin. Not commonly used in our applications. We look at more common uses of Celsius. This gives us that definition or conversion for Celsius temperature. The farad is the capacitance of a capacitor between the plates of which there appears a difference of potential of 1 volt when it is charged by a quantity of electricity equal to 1 coulomb. So here, a derived unit ends up being a combination of derived units. A coulomb is a derived unit. The volt is a derived unit. So together, they are defining another derived unit. I won't read through all of these, but you should be familiar with these. These are things that will come up in the course of our class. These are things when you're talking about energy, electrical machines, power, all of those things that are related to this. This is the terminology that we need to know. We need to know what a joule is. We need to know the Newton, this measure of force. We need to know what what electrical resistance is measured in ohms, a unit of pressure. One other I'll point out to you, the Siemens is a unit of electrical conductance is equal to the reciprocal of the ohm. And it is interesting to me that at one time, Siemens were formerly named MHOs or MOs, which is ohm spelled backwards, which to me seemed to make a lot of sense, but for some reason that was done away with. Tesla, we'll use that a lot when we're discussing magnetic flux density, because we're going to see throughout our study of electrical machines that the magnetic field is the medium where we convert one form of energy to another form of energy. And that is what electrical machines do. The volt, defined here, the watt, it's the power that gives rise to the production of energy at a rate of 1 joule per second. The Weber is the magnetic flux. And again, here the Weber is used to define the Tesla. So all of these things combined to give us these derived units and these names for those.